This is the AB43 review. Calculators are not allowed, and it's number 3. Now on this one we are given a particle's position function, and based on it we want to list or describe the particle's motion on the time interval given. So there's a whole host of things that I could ask on the test that involves this type of a problem. So with each of them we have a position function. We will get, and the position tells us where we are. We can get how we're moving if we take the derivative and get the velocity. We can also get the push, which will tell us whether we are slowing down or speeding up if we look at the acceleration. So let's start at part A, where we are given the position function and we want to find the acceleration and, the velocity first and then the acceleration. So the velocity is the first derivative of this, which would be a 3t squared minus a 4t minus a 4, and the acceleration is the derivative of this, which would be a 6t minus a 4. So if we look at these, both of them, we want to be able to find out when they equal 0. So this will be the same as a 3t times a t, and let's see, we need a negative 4, so we could do a negative 2 and a positive 2. Let me double check, negative 6, positive 2. That's going to equal 0 at t equals positive 2 or negative 2/3. On this one, we can factor out a 2 and get a 3t minus 2. That will equal 0 when t is 2/3. So we are on the closed interval from 0 to 10. So what I'm going to do here is I'm going to draw a sign chart for the velocity function and a sign chart for the acceleration function, because using those we can then determine when the particle's moving left, when it's moving right, when we're having a max position, a min position. We can look at when we are speeding up and slowing down. So on each of these we're going to put our domain, which is 0 to 10, and then on the velocity curve in that domain we only have one critical value at 2, and with the acceleration we only have one at 2/3. So prior to 2 on the velocity curve, say at 1, this is positive, this is negative. So that means we're traveling left until time 2. After time 2, they're both positive, so we will be greater than 0. For my acceleration curve, prior to 2/3, say at 1/3, we would get a 1 minus a 2, that's a negative. And after 2/3, say at 1, we will have positives everywhere. So the acceleration tells me that I'm pushing left and then I'm pushing right. So we can see and summarize from here a lot of different things. We can say we move left from 0 until 2, then we move right from 2 until 10. We can talk about when we stop, which is at 2. We can talk about the minimum position occurring at 2, and in order to find the minimum position we would plug the 2 into the function value and get a 3 out. Or we could talk about speeding up and slowing down, or when the velocity is constant. So the velocity is constant when there is no push. That happens at 2/3. When I'm pushing left and moving left, I will be speeding up. So I'll speed up from 0 to 2/3. When I'm moving left and pushing right, then that means I'm going to be slowing down from 2/3 to 2. When I am moving right and pushing right, then again I am speeding up. So I wrote up a bunch of stuff on the key that you can look through. There's also some more online if you look at my solutions, but pretty much I'm going to be asking some variation of the theme. So you need to be able to read everything off of these sign charts.